Hello guys, prime concept. We want to look at image formation on a convex mirror. In our previous videos, we considered image formation on a concave mirror, and we considered 6 different positions of object. Now for a convex mirror, irrespective of where you place your object, the image will be formed on the same side. So we have only one condition to consider for the convex mirror. I'll be drawing that so that you can understand the concept. If you have been following my channels, please do well to hit the subscribe button, like my videos whenever you come across them, and then comment and share with your friends so they can also benefit. And let's look at it. Now say this is our convex mirror. Let me draw it very well. So say this is my convex mirror. Not still very straight, but let me manage this. So this is my convex mirror and this is my principal axis. Of course, you know that for your convex mirror, the focal point will be located within the sphere. This is our sphere. So our focal point will be here, not here, even though this is our reflecting surface, right? So this is where I will have my focal point F. And then this is my center of curvature. So this is where we place objects because this is our reflecting surface. So I would have, consider my object here. You can see there's no specific label here. So it means your object can be anywhere around here. And that is what makes that our convex mirror gives us only one condition, depending on where our, irrespective of where our object is. Now let's do this using the rules we've known. If I incident parallel ray, this parallel ray would appear to pass through my focus, even though that is not what happens in real case. So, but then when this parallel ray hits my mirror, it will bounce back like this, looking as if it was coming from the focus or the focal point. Now, if we draw another ray from our object through our center of curvature, we'll have something like this. So if we draw, we have something like this. So this is another one. Remember, when you draw a ray through your center of curvature, what happens to it? When you draw a ray through your center of curvature, what happens to it? It goes straight and returns in the same direction. So it will return in the same direction. Now, where do these two rays, reflected rays, intersect? You can see that this is where they intersect. So this is automatically where our image I will be formed. Now, if you consider this, from this diagram, we can outline the properties of this image that is formed for a convex mirror. And this is the only condition we can have for a convex mirror. So the properties of the image formed. Number one, we can see that the image is formed. I hope you are aware that this is the back of your mirror. So you can see that the image is formed at the back of the mirror. Image is formed behind the mirror. So image is formed behind or at the back of the mirror. Number two, we can clearly see that if your image is formed at the back of the mirror, it simply means that your image is virtual. So image is virtual. So it's a virtual image. Number three, now of course, you know, if you form a virtual image, automatically that virtual image will be erect. And you can obviously see that this image is standing erect, upright. So image is erect. Image is erect, or you can say upright. Now number four, this is my object. Consider the size of this object relative to the size of this image. You can simply tell that the image is diminished or the image is smaller. So image is diminished. So image is diminished, right? So these are the concepts you can actually get from a convex mirror. These are the properties. I believe that this concept is really very clear to you. Do well to always drop your questions in the comment section. Refer to any topic you would want me to handle and I would listen and then handle that. Thanks for watching my videos. Do well to subscribe to my channel. This is Prime Concept.